credited with developing some weird computer language. I know. All right. Here we go. Everybody's paying attention. Obviously, boys and girls, there isn't much room on this sheet, so if I were sitting where you're sitting, I'd have a sheet of notebook paper out, and I would be giving myself plenty of space to do the work rather than writing in the margins and all around. But you do whatever you want. I would suggest you use on a separate sheet of paper. All right, here we go. We're going to write a linear function given this information. Who remembers? What do we do?
2, 3, you're going to find
These are ordered pairs. We're doing a linear function, which means line, which means slope, right? We only do slope with lines. This is linear, it tells me in the problem. So it looks like my slope is 7. So then what happens? Pick a point. Y minus the y coordinate equals slope x minus the x coordinate. And it looks like my function is 7x minus 11. How does that look at my linear function? B, a polynomial function whose zeros are 2 and 3 plus I. What do we do with this? Yes, very good, Jimmy. First of all, we have 3 roots here. Because if 3 plus I is a root, so is 3 minus. They come together. What factor does that correspond to? X minus 2. What factor does that correspond to? X. Watch it. Then you subtract. You pull this over. So x minus 3 minus I. And this one would be x minus 3 plus I. Kids, when you put them in the parentheses, you have to change your signs. Now, I always say FOIL these two. Big FOIL. But do those first because all of the I stuff is going to cancel out. So we'll just multiply. We're going to multiply all 3 of them. That would be these 2 first. So, right down the line. My own personal style is I take x times boom, boom, boom. Then I take negative 3. Negative 1. You do whatever you want. Just make sure that all of these are getting multiplied by all of those. These cancel. These cancel. And what about negative I squared? It doesn't really cancel, but you can change it into plus 1. So now we have x squared minus 6x plus 10. Not the answer, because I still need to multiply it by x minus 2. So x cubed minus 2x squared. Again, this is just a big FOIL. Just get organized, do whatever you want. Nothing cancels here, but you do have like terms. Here's what I got. How about you? Sometimes when we do these, we find that A. How come I'm not finding an A this time? What do I not have that I need in order to do that? Another point, yeah, I gotta have another point. If they don't give me another point, then I have no idea. So this is gonna have to be good enough right here. All right, C, I already did one of these today. In order to do this, you simply have to remember that the vertex form of a parabola looks like this. I'm totally making this up. It has nothing to do with the actual problem. I'm just remembering that's what a vertex form looks like. This has a vertex at 7, 5. So now I'm going to use that form, but my vertex has to be 1, negative 4. So write 1, down 4. Would you agree with that for this problem? What do I need to figure out? That? And did they give me an extra point this time? Yep. So I'll plug that in. So here is my quadratic. All right, anybody have a question about PowerPoint? Got to figure it out? All right, to describe how this parabola compares to the parent. So you got regular old x squared. How does this one compare? What have we done to it? Left 1, down 9, and stretched by a factor of 2, twice as tall, pulled up twice as high. So if the original, here's the original, and this point is 1, 1 in the original. If we stretch that, the point of the new one is going to be 1, 2. It's going to be skinnier because it's been stretched, multiplied by 2. Height is doubled. Find the quotient and remainder. What goes in the box? Problem 3. What goes in the box? 2. And here's where I'm devious. Did you notice you need a 0 in that division? Why do we need a 0? X cubed is missing. And this synthetic division, nothing can be missing. So if something is missing, you have to put in a zero. If two things are missing, you put in 2 zeros. Got it? We get excited on test day, plowing through, you've got to be able to work out for that. Okay, here we go. Did I do that right? Anybody else did 69 out here? Did you really, or just copy mine down? You got it? Okay. I just want to make sure it's right before we go on. So I need to find the quotient and the remainder. So what's my quotient? 3x cubed. Why is it x cubed? Because the original was x to the fourth, and I go down one. So 3x cubed plus 6x squared plus 21x plus 34. And then my remainder is 69. Clearly, x minus 2 is not a factor. Because if it had been a factor, that number would be 0. And it's not. Could number 4 be done the same way? Yeah, but how hideous would that be? Why would it be hideous? Because there's a lot of zeros. So, who remembers the other thing we talked about as a possibility if all we want to know is the remainder? We don't care about this quotient. All we have to do is plug in the number we would have divided by, which is -1. So 3 times -1 to the 100th, 4 times -1 to the 5th minus 10. A negative to an even power is going to be positive, so it's 3 plus 4 minus 10. I got -3 as my remainder. Did you? Number 5. Kind of the same question. Because if we want to know if it's a factor or not, don't we really want to know what the remainder is? Because we need the remainder to be 0. So if we do the division, what would go in the box? -3? Oh boy. Question is it a factor? Yes or no? Yes. And why is it a factor? Because the remainder turned out to be 0. Could you, instead of doing the division, that wasn't bad division, but instead of doing that, could you have plugged -3 into this? Could you have plugged -3 into here? Sure. And what will happen? You'll get 0. That's how you can find the remainder, by plugging in. All right, number 6. Find an upper bound for the real rows of this polynomial. What does it mean to be an upper bound? It means you're going to divide by it, and what's going to happen?
It doesn't.
They're all positive. So if I'm left on my own to find an upper bound, I'm gonna pick a bigger number. Does that make sense to you? I have a better chance of picking one if it's bigger. So maybe I'll try 4. Actually, not 4, let's try 5. So here we go, my division. Did I find an upper bound?
Yes.
I did. Because all of the numbers in the bottom row are positive. Do you think 6 would have worked? 7, all those numbers would work. So in this case, you're just picking one. And then the last one, we had big down the line. Last one, list the possible rational roots. Now remember, it says list. So I want to see a list. You can use plus or minus, you don't have to use separate. So what do we got? Factors of 3 over factors of 2. So that'll include 3 and 1 for sure. What else will it include? 3 over 2 and 1 over 2. So there is your list of possible rational.
Hello, Pedro. A quick reminder that turning back to the national if you would like to join the public
We still have homework
Also,
out, let's get that
soon you will be
done
receiving
so we can
an
talk about it,
educator
questions
notice
answered.
to test the system once again. Thank you for your cooperation.